Hi, NR here. This question appeared in CET. Let us get the answer in few seconds. After that, let me explain how to get the answer using classical method. Classical method means using equations, different conditions, simplification, and finally the answer. This is a straight conductor, arc straight conductor. This is 3/4 of an arc and there is current through the conductor. This is not the answer, this is not the answer. Among these two, this is the answer. See, I can get the answer in 10 seconds after reading the problem in 10 seconds, and you should be able to get within 10 seconds because you are the one who is taking the exam, not me. Good. Now let me explain how to get the answer, and before that, students, do you want to learn such shortcuts with explanation? Then link is in the description box. Go to Google Play, download our class, go through free content in chapter-wise solution on previous year question papers in CET. Chapter-wise solution on previous year question papers in CET. Just go through free content. If you are happy, then buy the course at $9.99 using promo code 999. And believe me, this course is worth lot more than $9.99 and give an edge to your preparation. Now, shall I explain how to get the answer? See, this is a straight conductor. This point is at one end of the straight conductor. If this is a straight conductor carrying current, then magnetic field at any point, this is there in the NCERT syllabus. Magnetic field is constant 2I by R. This is applications of Ampere circuit law. And the constant is mu naught by 4 pi. Done. But there is a slight twist. This point is at one end, means something like this. This is the point. Point is at one end of the straight conductor means magnetic field is constant I by R. Constant I by R. At any point, 2I by R. At one end, I by R. Okay, make a note of it. There is a general expression. We are not going into details of that right now. And from that general expression, this is special case at one end and I by R. This is sufficient for CET. Now, there is arc carrying current, and this is 3/4 of a circle. 3/4 of a circle. 3/4 of a circle. Magnetic field due to an arc. 3/4 of circle means constant 2 pi Ni by R. This constant is again mu naught by 4 pi. And make sure that n equal to 1. Only one term, because conductor is bent into an arc. This conductor is along the radius. Is along the radius means this will not give any magnetic field. So B equal to 0. So forget this. So magnetic field at this point is due to straight conductor and 3/4. Straight conductor and 3/4. Now their directions. This is straight conductor. Direction of current. Thumb should be in the direction of current. Thumb in the direction of current. Curvature of fingers into the board. So this magnetic field is into the board. Magnetic field at this point is into the board. Now, because of this arc, curvature of right hand fingers should be in the direction of current, then thumb gives the direction of magnetic field. So this second magnetic field is into the board. These two are into the board means they are added. Resultant is sum of these two. Now we have to find the resultant, their sum. Identify the common factor, constant I by R, constant I by R. Now remaining constant I by R gone, 1 plus in this 2 1, 2 2, I by R is out, pi 3 pi by 2, 3 pi by 2, and this is the resultant magnetic field at this point. Say constant mu naught by 4 pi, I by R 3 pi by 2, 3 pi by 2 plus 1. Now, why did I choose this and not this? Why did I drop these two? Since it is in clockwise, see, since it is in clockwise, the magnetic field should be in the same direction. Means vector sum is plus. There is no plus here. So just drop. Second thing, out of these two, why did I choose this? This is pi by 2. Pi by 2 is 1/4 of an arc. Sorry, 1/4 of a circle. But this is 3/4. So it should be other than pi by 2. See, certainly I did not calculate this. Okay. Pi by 2 is not the answer. That's for 1/4. It's more than 1/4. Therefore, this should be the answer. That is how guesswork should be done. Behind every guesswork, there should be logic. Students, please note, behind every guesswork in such multiple choice question, there should be a logic. And guesswork should not be like this. There are 3 tube lights in the classroom. Therefore, C is the answer. No, please don't do that, because that will be killing your time and concentration. So make sure that logic behind guesswork. Galvanometer produces deflection of 100 divisions. When shunt of 1 ohm is connected, deflection reduces to 1 division. Then the galvanometer resistance is, galvanometer resistance G produces deflection of 100 divisions. 100. If it is shunted with 1, then division becomes 1. Deflection is 1. Deflection is 1 when shunted with 1 ohm. So G by G plus 1. Divide one by the other. This G get cancels with this G. 1 by G plus 1 equal to 1 by 100. Means G plus 1 equal to 100 and G is 99. Using regular method. This is a galvanometer. Certain current means current is constant. There should be a source which gives deflection. So V equal to IR. Ohm's law, isn't it? But current is constant and resistance of the galvanometer is G. So in place of R, let me write G. And this is the source. Due to this, there is deflection. And voltage sensitivity of a galvanometer, recall that expression, V by phi by V equal to N A B by K R. This phi deflection is directly proportional to voltage. Deflection is directly proportional to voltage. If ratio of two quantities is a constant, then these two are directly proportional. V directly proportional to phi, where phi is deflection. See, V is directly proportional to phi, deflection proportional to G. That's why I used this. Now come back. Galvanometer resistance G, 100 deflection. 100 deflection, galvanometer of resistance G. This is first case. Of course, proportional. Second case, one division reduces to one division. Reduces by one division is different. Reduces to one division is different. So this is one division deflection. proportional to galvanometer is shunted with a resistor. 1 ohm resistor. 1 ohm resistor. See, these two are in parallel. These two are in parallel means it is G into 1 by G plus 1. Hope you got it. R1 plus R2 by R1 plus R2 is the resistors in parallel, equivalent resistance in parallel combination. So G by G plus 1. G into 1 by G plus 1. G into 1 by G plus 1. Now I have two equations. Divide one by the other. G get cancels with this G. 1 by 100 is 1 by G plus 1. 1 by 100 is 1 by G plus 1. Therefore 100 equal to G plus 1. If this is the case, then G is 99. See, to understand and solve this problem, we should use voltage sensitivity. And there you have to find that these two are directly proportional. Second, make use of Ohm's law. And there current is constant. You should identify that current is constant for certain current in both the cases. Then this simplification. Magnetic field at the center of a circular coil of radius r due to current is B. Magnetic field at a point along the axis at a distance r from the center is no. This is the answer. Now, how to get the answer? Now, let me explain how to get this. This is a circular coil carrying current. Magnetic field at the center of the circular coil is constant 2 pi Ni by R. This constant is mu naught by 4 pi. So every time this is same, mu naught by 4 pi. Don't worry. Now, magnetic field at some point on the axis at a distance equal to radius. And this magnetic field is B dash equal to this magnetic field compared to this is B by root 8. Why it is B by root 8? This point is on the axis. Big formula. It is there in NCERT. Constant 2 pi Ni R square by R square plus X square whole to the power of 3 by 2. This is mu naught by 4 pi. Where X should be equal to R. This is the given condition. Substitute X equal to R. So this becomes R square. R square plus R square is 2R square. Of course, small r or capital R. 2R square. 2R square. This is small r. So let me use small r. Now concentrate on R. R square. R square square root. R cube. R square by R cube is R. 2 pi Ni. In the denominator there is R. This is constant. Now 2. 2 cube is 8 under square root. So it is root 8. Now this is B dash. Observe constant 2 pi Ni by R into root 8. With respect to this, this is extra. Means we can write B dash. B dash. This B dash is B times B by root 8. B times 1 by root 8. That's why I chose this. So just play a little bit with the equation with different answers, with different cases. X equal to R, it is root 8. If this is another point P dash where x equal to 2r, then this magnetic field is B by 5 root 5. Just play with this equation, substitute x 2r and then find it is B by 5 root 5. So next time, if there is distance 2r, then answer should be B by 5 root 5. If distance is just r, then B by root 8. If distance is 0, then magnetic field at the center, it is just B.